Now let us solve some problems. Find the transfer function and the impulse response of the system described by difference equation. Now here difference equation is given to you and you have to find the transfer function also impulse response. Given y of n minus 1 by 2 y of n minus 1 is equal to 2 into x of n minus 1. Let us take this equation as equation 1. Taking z transform on both sides, we get y of n z transform is y of z minus 1 by 2 z inverse y of z is equal to 2 times z inverse x of z. Now taking y of z common from these two expressions, we get y of z into 1 minus 1 by 2 z inverse is equal to 2 z inverse into x of z. Now rearranging the terms, taking this x of z down, and this term here we get h of z is equal to y of z by x of z is equal to 2z inverse by 1 minus 1 by 2 z inverse. Now we apply the formula. This 2 is a constant, will take aside, and here 1 by 2 whole raised to n u of n is 1 by 1 by 2 z inverse, but here we have a z inverse that is nothing but shifted version of the signal. Therefore h of n is equal to 2 into 1 by 2 whole raised to n minus 1 u of n. Let us see another problem. Find this transfer function and the impulse response of the system described by difference equation. Here difference equation is given. Y of n minus 1 by 4 y of n minus 1 minus 3 by 8 y of n minus 2 is equal to minus x of n plus 2 times of x of n minus 1. Y of n is equal to 1 minus, so let us take this as equation 1. Applying z transform on both sides, we get y of n z transform is y of z minus 1 by 4 y of z inverse into y of z minus 3 by 8 z raised to minus 2 into y of z is equal to minus x of z plus 2 times of z inverse x of z. Now taking y of z and x of z common on LHS and RHS, we get y of z by x of z as this minus 1 plus 2 z inverse by 1 minus 1 by 4 z inverse minus 3 by 8 z inverse. Now taking the fractions of this one, splitting into factors, we get this one. Now taking this whatever the expression is there, applying partial fractions expansion, we get h of z is equal to, let us do like let us see an partial fraction, how to simplify a partial fractions. A by, let us take here, if you see here, whatever the term is there, here we have in the denominator we have two terms, so we take a divided by something plus b divided by something. So here a by 1 plus 1 by 2 z inverse plus b by 1 minus 3 by 4 z inverse. So here if you take cross multiply here and taking LCM, since denominators are same, in order to become this LHS becomes to RHS, numerator has to be same. So equating the numerator here and collecting the coefficients of constant and z inverse, equating to the right hand side, a plus b is equal to minus 1 minus 3 by 4 minus 3a by 4 plus b by 2, here constant, simplify. Simplifying these two equations, we get a equal to minus 2 and b equal to 1. So h of z is equal to minus 2 1 plus 1 by 2 z inverse plus 1 by 1 minus 3 by 4 z inverse. So taking inverse, apply inverse z transform to this one, minus 2 is a constant, we'll take here, so this is minus of minus, we'll write as minus of minus, minus 1 by 2 whole raised to n u of n plus 1, here 3 by 4 whole raised to n u of n. This is the impulse response of the given difference equation. Now let us solve the model paper problems. So this is a model paper 1, 10th B question, which is for 8 marks. A stable and a causal LTI system is described by the difference equation. Here given the difference equation, y of n plus 0.25 y of n minus 1 minus 0.125 y of n minus 2 is equal to minus 2 times of x of n plus 1.25 x of n minus 1. So we have to find the system impulse response, h of n we have to find. Now here taken this difference equation, will take as equation 1. Now, so in order to simplification, I will take 0.25 as 1 by 4, 0.125 as 1 by 8 and 1.25 as 5 by 4. So apply z transform to the above equation. We get y of n is y of z plus 1 by 4 z inverse y of z minus 1 by 8 z raised to minus 2 y of z is equal to 2 times of x of z plus 5 by 4 z inverse x of z. So taking y of z and x of z common from these two terms, so we get y of z by x of z, which is nothing but h of z transfer function. We taking this term down and taking this x of z here, we get here this term. Now similarly, applying the splitting this expression by partial fractions, here in the same method, a by something. So take here taking LCM and equating the numerators, we get constant a. This is a and b are constant. This constant is equivalent to this one. Then only these two numerators will become equal. Now here, so a plus b is equal to minus 2 minus a plus 4b plus b by 2 is equal to 5 by 4. Both these expressions, solving these two expressions, we get a equal to minus 3 and b equal to 1. So h of z equal to y of z by x of z is equal to minus 3 by 4 plus minus 3 divided by 1 plus 1 by 2 z inverse plus 1 by 1 minus 4 by 1 by 4 z inverse. Taking inverse z transform, h of z, you get h of n is equal to minus 3 minus 1 by 2 whole raised to n plus 1 by 4 whole raised to n into u of n. This is an important question, 8 marks question. Let us solve another problem, 9th C, where an LTI system is described by the impulse response. Impulse response is given here. Determine input to the system. What input we have to give to the system if the output is given as y of n is equal to 0.5 whole raised to n u of n plus minus 0.5 whole raised to n u of n. So let us take this as equation 1, and this 0.5 we are writing as 1.1 by 2. Only for your convenient case, I'm writing here. If you want, you can take as a 0.5 and further go for the simplification. And minus 0.5 I'm writing as 1 minus 1 by 2. Now applying z transform to this equation, we get y of n. Z transform is y of z is equal to here 1 divided by 1 minus 1 by 2 whole z raised to minus 1 plus 1 by 1 plus 1 by 2 whole z inverse. So here simplifying this one, here this is like a plus b, here taking cross multiplication, and this is into a plus b into a minus b. So here also h of n is given as 0.5 whole raised to n u of n. Now applying here I am writing 0.5 as 1 by 2 whole raised to n u of n. H of z is equal to, applying z transform, h of z is equal to 1 by 1 minus 1 by 2 whole raised to z raised to minus 1. So here we know that h of z is equal to y of z divided by x of z. But here we want input signal where impulse response and output are given. Therefore x of z is y of z by h of z. Now simplifying this one, this expression x of z here 2 divided by this one. Now simplifying this one, rearrange the terms and simplifying this one, x of z is 2 divided by 1 plus 1 by 2 z inverse. So simplifying x of n, in taking inverse z transform, x of n is equal to 2 into minus 1 by 2 whole raised to n u of n. Using the formula a raised to n u of n, z transform is 1 by 1 minus a z inverse. So we'll solve one more problem here, where determine the transfer function of a difference equation representation of LTI system described by impulse response. Here only impulse response is given to you and you have to determine the difference equation. So where h of n is 1 by 3 whole raised to n u of n plus 1 by 2, this n minus 2 I am writing as n minus 1 minus 1, because here you have n minus 1, so I am trying to get in this form equation 1. So this I am using the formula a raised to m minus n as here this form. So this I am writing separately. So applying z transform, here h of n, z transform is h of z, and 1 by 3 whole raised to n u of n, z transform is 1 divided by 1 minus 1 by 3 z inverse plus 2 into here shifted version, therefore z n minus k, therefore z raised to minus k, z raised to minus 1 divided by 1 minus 1 by 2 whole raised. Here we know that z transform of x of n is x of z, then shifter version of the signal will be z raised to minus k x of z. So here this is the shifted version of the signal. Now taking LCM and simplifying this one, you get this expression 1 plus 3 by 2 z inverse divided by 1 minus 1 by 3 z raised to minus 1 plus into 1 minus 1 by 2 z inverse. So this expression h of z is nothing but y of z by x of z. So cross multiplying this one here and here h of z is equal to y of z by x of z. So cross multiplying you get this one, and multiplies this y of z and also x of z in the inside, and taking the inverse z transform y of n minus 5 by 6 y of n minus 1 plus 1 by 6 y of n minus 2 is equal to x of n plus 3 by 2 x of n minus 1. This is the difference equation. Now we'll do same model paper 10th equation, 4 marks question. Find the z transform of x of n is equal to 0.5 whole raised to n u of n plus 2 raised to n u of minus n minus 1. Now we know the formula z transform of x of n is given by sigma n equal to minus infinity to plus infinity x of n z raised to minus n. So here z sigma will, whatever the x of n is there, will substitute here. So 0.5 whole raised to n u of n plus z 2 raised to n u of minus n minus 1 z raised to minus n. Now this 0.5 whole raised to n I am multiplying here, and the limits will change since u of n exists from 0 to infinity. Less than infinity it is 0, therefore our limits will change from n equal to 0 to infinity. Now u of n minus 1, we'll see how is u of n minus n minus 1. This is u of n which is 1 from 0 to infinity. U of n minus 1, shifted version of this signal from 1 to infinity, and folding this signal minus infinity to minus 1. Therefore minus infinity to minus 1, 2 raised to n z raised to minus n. Now sigma n equal to 0, 1 by 2 z inverse whole raised to n, and this limits whatever n equal minus infinity to plus infinity will change, minus will change by plus by taking n equal to minus n. Therefore wherever n is there, take as minus n. So that will become this. Now we know the formula sum to infinity is a by 1 minus r, where a is the first term and r is the common ratio in geometric progression. Therefore 1, a is 1. We can write down this expression as 1 plus 1 by 2 whole raised to 1 plus 1 by 2 z inverse whole raised to 2, and so on. So first term is 1 divided by 1 minus 1 by 2 z inverse plus 2 times 2 inverse, whatever 2 inverse is there. So this is starting at 1. Therefore the formula is n equal to k to infinity alpha raised to n is equal to alpha raised to k by 1 minus r. Therefore 2 raised to minus 1 z divided by 1 minus 2 raised to z. Thank you.